So I think, yeah, I think you can record the session now.
I have pressed the button record. Is it showing?
Yes, we have got the message. Okay, we have got the message that the session is being recorded. Okay. So may I ask the participants, did you face any difficulty in the last class? And if it is so, what were the difficulties that you actually faced, so that I can review those issues once again? Okay, to remind you, in the last class, I have actually discussed some statistics such as skewness, kurtosis, then quartile, percentile, okay? Standard deviation, then 5% trimmed mean. All these things actually I discussed in the last class. So did you face any difficulty in understanding those statistics? Did you face any problem? Anybody?
Sir, it would be
Yes.
great if you please repeat again the interquartile range.
Okay. So let me quickly review all those things. I think we understand mean, median, mode. So there is no question to discuss mean, median, mode. Everybody knows, right? Mean, median, mode. We understand what is a standard deviation, correct? And we have also discussed the use of standard deviation in our clinical practice. Did I?
Yes, sir.
Okay, standard deviation, remember that is a measure of dispersion. We calculate the dispersion against the mean. The standard deviation actually indicates the average difference of individual observations from the mean of a data set. So it indicates what is the average difference of all these observations from the mean. Okay. Standard deviation, if the standard deviation is small, it indicates that the individual observations are close to each other. If the standard deviation is big, it indicates that the observations in the data set are different, very different from each other. If the standard deviation is equal to 0, then what would happen?
All data are at the center.
If the
uniform, all the same.
All the data are same, okay? Yes, there is no deviation. So like this. And we said that in our practical life, suppose we have 2 drugs to reduce blood pressure, and the literature shows that both these drugs on an average reduce the systolic blood pressure by 5 millimeters of mercury. Both these drugs on an average. But drug A, the standard deviation of drug A is 1, and a standard deviation of drug B is 3. So the drug A has a smaller standard deviation. That means that if you use drug A, it will be consistent in reducing the blood pressure level. You can be sure that the blood pressure would be reduced, say plus minus in general, say plus minus 5 millimeter of mercury is something like this. But if you consider 95% confidence level, then it would be plus minus 2. On the other hand, if you use the other drug, it's not that consistent. That's why in clinical practice, if both the drugs are similar in side effects and other problems, then it is preferable to use the drug which has smaller standard deviation. Okay, am I clear? Am I clear?
Yes, sir.
Okay. Skewness and kurtosis, these two statistics, practically we do not use them. Okay, practically we do not use them. We have better statistics. Okay, skewness and kurtosis, the statistics of skewness and kurtosis, we consider to understand whether the distribution is symmetrical or not. A symmetrical distribution is consistent with normal distribution. Sometimes we use the skewness and kurtosis to understand whether the distribution is symmetrical or not. Skewness indicates spreadness of the distribution, whether data is skewed to the right or skewed to the left. Skewed to the right, if the data is skewed to the right, then we can see that there would have a tail on the right-hand side if we construct a histogram. I will show you. And if the tail is on the left-hand side, we say that the data is skewed to the left. Skewed to the left is also called negatively skewed, while if it is skewed to the right, sometimes we also say that the data is positively skewed. And this figure shows the normal distribution, where the distribution is symmetrical. Distribution is symmetrical. Okay. On the other hand, kurtosis indicates peakness or flatness of the curve. Okay. Peakness or flatness of the curve. For a normal distribution, the distribution, the peakness has a certain amount of peakness. It should not be too peak or it should not be too flat. There are several terminologies to describe this flatness. Very honestly, in reality, you don't need it. We have alternative statistical methods. Okay? Am I clear?
Yes, sir.
In SPSS, ideally, okay, before that, ideally, if skewness is equal to 0, it indicates that the distribution is perfectly symmetrical, okay? If it is equal to 0, both for skewness and kurtosis. However, since we are working with the sample taken from the population, hardly, perhaps you will never find that skewness is 0, kurtosis is equal to 0. In SPSS, if we have the skewness -1 to +1, then we may consider that the distribution of the data in the population may be symmetrical. Similarly, we also need to have the value for kurtosis between -1 and +1 to say that the distribution is symmetrical in the population. Okay, but once again, I am telling you that mostly we do not use these statistics for our practical purposes. Am I clear? So if you do not remember it, forget it. Okay? Okay?
Okay, sir.
Fine. Next, come to quartile. Quartile, we are using these statistics, particularly the IQR. Before that, what is a quartile? If we arrange the data into ascending order means small to large. Then if we divide the data set into 4 equal parts, each part is called a quartile. Clear?
Okay, sir.
So suppose in a report, we have found that the Q1 of the commercial sex workers, age of the, Q1 of age of the commercial sex workers is 20 years, okay? What does it mean? The Q1 of age of commercial sex workers is 20 years. It means that 25% of the commercial sex workers' age is 20 or less than this. Am I clear?
Yes, sir.
Okay. And interquartile range is equal to, we calculate interquartile range if we deduct Q1 from Q3. Okay. Q1 from Q3. So Q3 minus Q1 is the interquartile range. I will show you how to get these statistics a little bit later. Am I clear?
Yes, sir.
So interquartile range. Okay, so interquartile range. Next is 5% trimmed mean. Suppose you have a data of 200 subjects, okay? You have a data of 200 subjects. Now arrange the data into, say, ascending order. And 5% of 200 is how many? 10, right?
Yes, sir.
If you ignore 10 data from the top and 10 data from the bottom, then the remaining 90% data, if we calculate the mean, that would be the 5% trimmed mean. Clear? So 5% trimmed mean of a data set is the mean of the data, is the mean after discarding 5% of the upper and 5% of the lower values. Okay.
Sir, how do we discard it?
Computer will do it.
We delete.
You will tell the computer. Okay.
Okay. So there's option to like trim the 5%.
Yes, computer will do it for you. That's why we are using computer.
Yes.
Okay. It is like your hand calculator. 20 into 5, if you just push the button, it is 100. So how the calculator has done is the matter of calculator, okay? Computer will give you the results. So in the last class, we discussed that the mean is affected by extreme values, outliers, okay? We discussed it, that the mean of a data set is affected by the distant values, which we call outliers or extreme values, okay? Now the question is, if there are some outliers in your data set, whether it has significant influence on the mean of the data set or not. To understand it, we use the 5% trimmed mean. To understand the influence of outliers in the data set, we just compare the 5% trimmed mean with the actual mean of the data set. If they are close together, it indicates that the outliers, if there are any in your data set, does not have any significant influence on the mean. Okay, I will show you, I will do it. Fine, so it is the trimmed mean. Lastly, outliers and extreme values. The outliers of a data set by definition is equal to Q1. Outliers are say Q1 minus 1.55 into IQR. If the values are greater than this, then we say that outliers are present. Okay? Okay? Or, oh, sorry, less than. It would be less than this or greater than Q3 plus 1.5 into IQR. Okay. Okay, for example, suppose in our data, our Q1 is equal to 20. Okay. Then our IQR is equal to, say, how much? Say 5. Okay. Suppose it is 5. Then it is equal to how much? 20 minus 7.5. Correct? 20 minus 7.5. Correct? 20 minus 7.5, which is equal to 12.5. So if there is any data which is less than 12.5, that would be an outlier. Okay?
Okay, sir.
Fine. We can identify outliers in several ways, like constructing a histogram, constructing a, we call it a scatter plot, or by constructing a box and plot chart. Box and plot chart is the easiest way, okay? And SPSS will directly tell you how many outliers are there, and simultaneously, it will also give you the ID number so that you understand the location of the outliers in terms of ID numbers. Clear? I will do it. I will do it for you. Okay? Okay, is it all right?
Yes, sir.
Okay. Finally, what I did not discuss is how shall we understand whether the data has come from a normally distributed population or not. Okay, I did not discuss it because we did not get time. Okay, so the normality of a data set, remember that. Oh, one thing I must tell you, that we check the normality of data set of a continuous variable. Sometimes people are asking me that it is the categorical variable. How shall I check the normality of data? We do not check the normality of data of a categorical variable. Clear?
Yes,
sir.
sir.
So we can check the normality of data of a continuous quantitative variable like age, systolic blood pressure, diastolic blood pressure, income, etc. Okay? We can check the normality of a data set by using some descriptive statistics, okay? By using some descriptive statistics like skewness and kurtosis. I already told it, did I?
Yes, sir.
So it is already done. However, we do not commonly use it. We can check the normality of a data set by constructing graphs like histogram, QQ plot, okay, commonly used. You can also have an idea about the distribution. If it seems that the distribution is more or less normal, then you can consider that the data has come from a normally distributed population. Okay. Remember that for parametric test, it is not said that data has to be perfectly normal. If the distribution is approximately normal, you can use the parametric methods. Therefore, checking the histogram, if it seems that, okay, more or less it is normally distributed, you can use the parametric test. Another method of testing normality of data is to use some formal statistical test like Shapiro-Wilk test. Another test is there. It is called one sample KS test, Kolmogorov-Smirnov test. Okay. Chi-square test is also available to check whether the distribution is normal or not. Okay, however, we don't need those things. Only remember that Shapiro-Wilk test. We can use this test to check whether the distribution is normal or not. Okay, now we shall see all these things together. Skewness, kurtosis, then IQR, okay, trimmed mean, etc. Please open your SPSS and the data file, data 3. Okay, so it is here.
How can I do the Shapiro-Wilk test?
we shall show you. We shall show you. Just open your SPSS and open the data file data 3. Okay. So have you opened? Once you open, please tell me that we have opened it.
Yes, sir.
Okay,
Yes, sir.
everybody? Okay, fine. So first of all, we shall see how to get the Q1, Q2, Q3. Okay? Let us see first. So go to Analyze, Descriptive Statistics, Frequencies. Click on Frequencies. We have done it earlier. Okay? Have you done?
Yes, sir.
Done? Okay. Suppose we want to see Q1, Q2, Q3 of age. Okay? Age and say income, both. So select age, push it into the variables box. Also income, push it into the variables box. Have you done it?
Yes, sir.
Click on statistics. Click on statistics here. Click on statistics. Done. Okay. I have clicked on statistics. You can see the quartile under percentile values. Just select quartile. Okay. This is what you need to do. Have you done it?
Yes, sir.
And if you want other
Yes,
statistics, you see there are many other statistical options given here. Okay, so let us also select skewness and kurtosis. Okay, have you selected skewness and kurtosis?
Yes, sir. Yes, sir.
Okay, then continue, then okay. Continue, okay. Continue, okay. So you can see the first table. Okay. Okay, can you see?
Yes,
Can
sir.
you see the first table?
Yes, sir.
Okay, so you can see that skewness for age and monthly income. And you see the skewness is negative, correct?
Yes, sir.
Yes.
Skewness. So what does it indicate?
The data is shifted to the left or
Okay,
skewed
there
negatively.
is, okay, the data is skewed to the left. Very good. But I said that if the skewness ranges between -1 and +1, we consider that the distribution is symmetrical, right?
Yes, sir.
So even though it is negative, but it is within that limit, -1 and +1, okay?
Yes, sir.
Therefore, we consider that the distribution of age is symmetrical. Also, monthly income is symmetrical. Okay? Okay?
Yes, sir. Yes, sir.
Okay. However, before we say whether the data is symmetrical or not, we should also simultaneously check the kurtosis. Okay, check the kurtosis. You can see that the kurtosis for age is minus 0.28. Okay, minus 0.28. Okay,
Yes, sir.
but is still within the normal limit. Clear?
Yes, sir.
Therefore, since both skewness and kurtosis are within the normal limit, we may consider that the distribution of age in the population is symmetrical. Okay? However, if we look at the kurtosis of income, it is minus 1 point something, exceeded the range. Okay?
Yes, sir.
So minus 1.106 means the distribution, the curve is flatter than the normal. And since it exceeded the normal range, we may consider that the monthly income may not have a normal distribution in the population. Okay? It exceed kore giyeche na, so it exceeded -1 and +1. Okay? Clear?
Yes, sir.
Okay. Now we can see that we have selected quartile, but SPSS did not tell us quartile, did not give us quartile. SPSS has given us percentiles. Actually, percentile 25 means Q1, okay? Because we said that if we divide the data into 4 equal parts. So one part is 25 percentile, okay? So this is the Q1, this is Q2 or median, and this is the Q3. So we can see that Q1 for age is 21 and Q75, Q1 and Q3 is 32. So what would be the IQR? 32 minus 21 is equal to 11, right?
Yes, sir.
Okay. Okay, similarly, it is for the income. So have you got it now? Percentile, sorry, quartile, skewness, kurtosis. Okay.
Yes, sir.
Now let us see how to get the trimmed mean. Go to Analyze, Descriptive Statistics, Explore. Explore. Click on Explore. Done.
Yes, sir.
Done. Explore. Okay. Now select age and income, because we have select age and income and push it into the dependent list box. Age and income, both. Okay. Have you done it?
Yes, sir. Yes, sir.
From the bottom, display, you can keep both, does not matter, okay? Or you can select only statistics, okay? Whatever you like. You can keep both, no problem, don't change it. Keep both, okay? Both means the computer will give some plots as well as statistics. Okay, let us click on statistics. We don't need to do anything. Okay, everything is here. Click on plots. Plots. Click on plots. Have you done it?
Yes, sir. Yes, sir.
Okay, from here, just select histogram so that we can get all these things together. Have you selected histogram?
Yes, sir.
Okay, now continue, then okay. Continue, okay. Continue, okay. Have you done?
Yes, sir.
Okay, now we can see. Can you see this table?
Yes, sir.
So we can see, just let us review the age. 5% trimmed mean how much it is?
26.560.
26.56. And what is the mean?
26.51.
5. So they are very close together.
Yes.
So this indicates that either there is no outliers in age, or if there are any outliers, they did not affect the mean. Clear?
Okay, sir.
Yes, sir.
Because they are very close together. If they were different, then we could conclude that the outliers present in age has influence on the mean. Similarly, if we look at the, you see, the monthly income, the 5% trimmed mean 85,227. It is 85,194. Again, they are very similar, correct? Correct?
Yes, sir.
Okay. You can see the interquartile range for age. We have calculated it as 11, right? So you see interquartile range is 11. Okay. Have you got it here?
Yes, sir.
So you can get all these things. So we know how to get them, correct?
Yes, sir.
Okay, now let us come back. You see, this is the histogram of age. So how does it look like? It looks like more or less symmetrical, correct?
Yes, sir.
Therefore, we assume that the distribution of age is normal in the population. This is stem and leaf chart. Okay, stem and leaf chart we use for small data set. Okay, commonly we use for a small data set. For, you see, in clinical trials, they are doing the studies with a smaller sample size, and there sometimes, occasionally, you will see that people are giving this stem and leaf chart. Okay, this is called box and plot chart. In the box and plot chart, we can see a box. The bottom border of the box indicates the Q1. Okay, this is Q1. Upper border of the box indicates Q3. And the middle one is Q4. Q2 or the median. Am I clear? Am I clear?
Yes, sir.
This one, the whisker, this is called whisker. The bottom parallel line indicates the minimum value. The upper parallel line indicates the maximum value of the data set. Okay? So you will find all these things in my book. Now you see, look at this monthly income. Very difficult to conclude looking at the histogram, right?
Yes, sir.
Okay, however, so this is the box and plot chart. Okay, one thing, let me tell you a little bit. If the distribution is symmetrical, then this, the median, will be lying at the middle of the box. Okay, have you got it?
Yes, sir.
Okay, and the whisker length should be similar on both sides for a normally distributed population, normally distributed data.
Sir, please
Okay?
repeat.
So, forget it. Don't, burden your brain. We have other methods. You see this one, the middle line indicates the Q2. For a normally distributed data, the middle line would be lying at the middle of the box. And for a normally distributed data, the whiskers would be of same length on both sides. Forget. Okay. So we have seen how to calculate the 5% trim mean and how to interpret it and the purpose. Now, finally, as I have said, how shall we understand whether the distribution of a data set is normal or not? For example, age. So we said that we can have an idea about the distribution of a data set by using the descriptive statistics, and that is skewness and kurtosis. I have already covered. Another option is looking at the graph. One of those is the histogram. So we have seen it, okay? Another way is to construct the QQ chart. So to construct the QQ chart, go to Analyze, Descriptive Statistics, QQ plot. Can you see it? Can you see it?
Yes, sir.
So click on QQ plot. Click on it. Okay, so we are here and we want to check, let us see both age and let us select systolic blood pressure, okay? We shall check both age and systolic blood pressure, okay? Done. Done.
Yes, sir.
Just click OK. Just click OK. Have you done it? Have
Yes,
you
sir.
done it? Just click
Yes.
OK. Okay, fine. Now you can see this is the QQ plot for age. And this is the QQ plot for systolic blood pressure. Okay. So if you look at the QQ plot of age, you can see that all the dots are lying on the diagonal line, on, not above, on, correct? All the dots are lying on the diagonal line. If the dots are lying on the diagonal line, it indicates that the distribution of the data is normal. Clear? Okay.
Yes, sir.
So just very simple. We want to see whether the dots are on the diagonal line or not. If they are on the diagonal line, we consider that the distribution is normal. Okay. Now look at the systolic blood pressure. You see there are some deviations at the middle, also at the tail. Okay. Deviation, there are some deviation, both ends as well as middle. So all the dots are not on the diagonal line. Therefore, the distribution indicates that the distribution may not be normal. Actually, if there are deviation at the ends, that may indicate that there may have outliers. Okay, outliers. Fine. Is it okay?
Yes,
now,
it is.
Finally, we said that we can also use statistics, formal statistical method to understand whether distribution is normal or not. One of those statistical methods is the Shapiro-Wilk test. Now go to analyze descriptive statistics, explore. Analyze descriptive statistics, explore. Click on explore. Done?
Yes, sir.
Done? Okay, done. So we want to see age and systolic blood pressure. Remove the income, select systolic blood pressure and push it into the dependent list. Okay. From the bottom, just select the statistics just to reduce the hassle. Okay. From display box, select statistics. Are you with me?
Yes,
Yes,
sir.
sir.
Okay. Now click on statistics. Click on statistics. Okay. Click on. Oh, okay. Let us see the options. No. Okay. We have to select the plots, not statistics. Okay. Or both. You can keep both. Better. Okay. Keep both. Have you selected both under display?
Yes, sir.
Okay, now click on plots. Click on plots. Okay, click on plots. Done.
Yes, sir.
Okay, now select here normality plots with test. Just select this option. Okay, normality plots with test. You can deselect others because we do not need them anymore. Fine. So select normality plots with test. Okay. Have you done it?
Yes, sir.
Continue. Okay. Continue. Okay. Then continue. Continue. Then, okay. So everything is done. So you can see this table, tests of normality. Do you see it? Do you see the test of normality? Do you see the test of normality table?
Yes, sir. Yes.
Okay. So you can see that the first part is the Kolmogorov-Smirnov test result. Second one is the Shapiro-Wick test results. Okay, can you see it?
কেন এরকম করতেছো?
Can you
সমস্যা কি?
see?
একে দিলাম না এগুলা?
Yes, sir.
Okay. So our interest is to look at the p-value, nothing else. P-value is indicated by sig, S-I-G. Sig means significance, okay? So p-value is indicated by sig, okay, sig. So we can see that the p-value for age under Shapiro-Wick test is point, how much?
0.200.
এই ওটা তো কলমগরব, আমি তো বলছি শেপিরো।
0.547.
0.547. Okay, so if this p-value is greater than, if it is greater than 0.05, then it indicates that the distribution is normal. Okay, am I clear? Am I clear?
Yes, sir.
So if the p-value is greater than 0.05, we should consider that the distribution is normal. Since the p-value for age is greater than 0.05, we will consider that the age is distributed in the population normally, okay? The distribution of age in the population is normal. But if we look at the p-value for systolic blood pressure, how it is?
It's not normally distributed.
Okay, because p-value is less than 0.05. Okay, have you got it?
Yes, sir.
Okay, fine. So far, any questions? So I have reviewed the whole previous class. Any question? Burning question. Okay, if you do not have any question, then I would like to request Dr. Parveen to continue the class with data management.
আমার হুজুর ফোন দিচ্ছে।
Okay.
কথা বলে ট্যাবে ক্লাস করবা, ধরো। ধরো না।
Thank you, sir.
Okay, so Dr. Parveen, madam, please, you please
Sir,
continue. Yes.
can I share your screen?
Oh, yes, I am allowing to share your screen. I'm allowing you, number one, chat. Let me stop share now. Screen. So Parveen madam, you can share your screen now.
Okay, sir. Thank you. I'll try my best.
কিছে? আচ্ছা।
আপনার ডক্টর জান্নাতুল ফেরদাউস, আপনার মাইক্রোফোনটা একটু করে নেবেন, মিউট করে নেবেন। ওকে, থ্যাংক ইউ ভেরি মাচ।
Thank you, sir.
Yes.
Now
please.
I'll start. Today our topic is data management. I think everyone understands what sir says and everyone know how to make the structure of data. and already known how is descriptive statistics and frequency distribution and others. Now we'll discuss data manipulation that are commonly needed during data analysis. In this session, we will recording of data. You know, there are two types of recording data. Number one, record into same variable, and number two, record into different variables. Usually, we use record into different variables. This will keep the original data of the variable intake. Are you understand? Did you understand, everyone? What I say?
Ma'am, can you please repeat?
Firstly, again, I repeat it. Okay.
Yes, ma'am, can you kindly repeat?
We discuss how to make recording of data. At first, we use the variable sex. And
ma'am, can you please share your screen?
Yeah.
Yes.
Can you please share your screen? Thank you.
At first, we use sex variable. Here, everyone see that here F is made.
Dr. Parveen, we do not see your screen. Could you please share it with us?
Sir, I already shared it.
But we don't see it.
Oh,
Could
sir.
you please check it?
Okay, sir.
अपनी स्क्रीन शेयर फुल स्क्रीन देन.
Oh, sir, আমি দেখছি না.
জি, শেয়ার ফুল স্ক্রিন দিলে তারপরে আপনি ডেস্কটপটা সিলেক্ট করে শেয়ার করবেন, তাহলে আপনি যেখানে যাবেন ওখানেই আমরা দেখতে পারবো।
স্যার পারমিশন দেওয়া লাগবে কিনা?
পারমিশন তো দিয়ে দিয়েছি আমি অলরেডি। মাল্টিপল পার্টিসিপেন্টস ক্যান শেয়ার সাইমালটেনিয়াসলি, এটা হলে ইয়া করতে পারবে।
Sir, I am trying.
Okay.
So just a minute.
Okay.
এটা শেয়ার করতে চাও, কনফার্ম করো। এটা শেয়ার করতে চাও?
হ্যাঁ হ্যাঁ।
Now we can see.
Okay, sir.
Now we can see. Fine.
Now we start the procedure. At first, we select the variable sex. If this data set, the variable sex is coded, X is female and M is male. Now we go to transform and record into different variable. Here we select sex variable and click in input variable. Actually, it is string variable. Now I am name sex1. In name box under output variable and label gender. Sorry. Gender. Then click in change. Please, everyone will do it. Now it change. Okay. Did you understand? Now we'll go to old and new variable. Please follow me. In value box, it was main, sorry, and small main, then I will replace it by 1 in new variable and then add. Again, in old value, in value box, female and value by replace by 2 in new value and then add. Then continue and OK. Continue and OK. This option of recording requires formation of a new variable. Here you have already saw record sex m equal to 1, f equal to 2 into sex1. And variable level sex1 is gender. Now close it. Here in variable view, we see that sex1, it is numeric value and decimal place here 2, but it had no decimal value. So it will be 0. Here label, here it is gender. Now in values, here we define one equal to male, then add value box this 2 and label female and then add and okay. Now we will see the data view. Here you see that 612113. Now we will analyze this by analyze, then go to descriptive statistics and click frequency. Now select gender, sex 1 and push it variable box. Then okay. It is called frequency distribution for the gender. Here male equal to frequency 77, percentage 36.7, female 133, and
we do not
percentage.
Dr.
Yes,
Parveen, we do not
yes,
see the output file.
Stop share demo, sir.
আমি বুঝতে পারছি না কেন।
Sir, now see you.
Can see now.
স্যার দেখা যাচ্ছে না এখনো?
এখন দেখা যাচ্ছে, এখন আসছে।
স্যার আমিও এই ইয়েতে অত ফ্যামিলিয়ার হচ্ছি না। ওকে স্যার।
Okay, so we can see it now.
Okay, sir.
Ma'am, can I ask a question?
Yes, yes.
Ma'am, what are the benefits of recording data in these two different ways?
Here,
yes, ma'am.
First of all, it was the string variable. We never, sometimes we cannot measure the string variable, and that is why we will take it by numeric value and then analyze it. Sir, apni kichu bolben?
Yes, so who asked this question? It is important question. Who asked this? What is the name?
Asma.
Asma, okay. In the first class, while we were discussing about generating a data file, we said that we prefer to create the numeric variables rather than string variables. The string variables has some limitations. In some analysis, we cannot use the string variable. For example, in ANOVA, in regression, you cannot use the string variable. Therefore, occasionally, it is necessary to transform the string variable into numeric variable. This is one of the purposes. Another purpose of recoding is that, for example, if we want to analyze data for logistic regression method, then the logistic regression wants the outcome as the greater value. Okay, for example, disease present, disease absent. The variable needs to be coded as 0 equal to do not have disease, 1 equal to have the disease. if the code numbers are reversed, for example, in your data set, your code 1 is have disease, 0 is do not have disease, then the analysis would not be appropriate. That's why occasionally we need to recode the data set, okay, to make it suitable for our analysis. Okay?
Okay, thank you, sir.
Okay. Anybody else? Any other question? So in short, if I tell you, suppose you have got a data from your friend, okay? Sometimes you will be working with the secondary data. In those data set, you may find that there are string variables. So if you want to transform those string variables into numeric variables, then this is one of the ways. There is another way that is perhaps easier to do it. We can also do it. Dr. Parveen, by automatic recode, we can also use automatic recode. Go to transform, then automatic recode. You can also use that option. Yeah. So remember that. So what Dr. Parveen has done is that she has generated a new variable. Whenever you select the option, recode into different variable, you see different variable, means the computer is telling that we need to have a different or a new variable for doing this. That's why she has generated another variable and given the name sex1, okay? But if you use transform into same variable, then we don't need to generate any new variable. However, if we select this option, generate into same variable, then the original data that you have entered would be lost. Okay, that's why we prefer and we also suggest you to use the second option, generate recode into different variable option to be on the safe side. Okay, am I clear? Am I clear?
Yes, sir.
Not yet, sir.
Not yet? Okay, what is the question? I mean, what is not clear? Hello? Hello, I don't hear anything. Okay, let us proceed and let us see. We will see. Fine. Dr. Parveen, please proceed.
Next, we will making class interval, sir.
Yes, you go ahead. You go ahead with,
okay,
your,
sir.
With your schedule, with your topics. No problem.
Now we will make class interval. For usual summarization, we need grouping the data into class interval or categories. In this data set, we want to categorize the variable age into 4 categories. Here is age variable. We shall use the option record into different variables in this exercise. Now we will go to transform and go to record into different variables. First, we remove sex variable. Now we select age. And in name box, we use age1 in output variable and label age group. And then change. Here click. Then old and new variable. Here we select range lowest through value 20 by 1 and then add. Now we select range 21 to 30 by 2, then add. Then 31 to 40 by 3, then add. And lastly, we use range value through highest 40 by 4, then add and continue and OK. Here we generate a new variable for this option is variable. From variable view, we see that age1, it is type numeric decimal place to level group age group. Now we define the value level. Here value 1 less than or equal to 20 and then add. Number 2, remove it. Value 1 less than or equal to 20 years. Yes. Then add the 2, 21 to 30 years. Then add number 3, 31 to 40 years. Then add 4 greater than 40 years. Then OK. This command will generate a new variable age1 with 4 categories of variable age as 1, 2, 3, 4. Now from data view, we'll go to analyze, select descriptive statistics and click frequency. Now select age group, push into variable box and then OK. Now everyone see that here the distribution of age group, here we see that 20 less than or equal to 50 patient or participant, and percentage is 23.8. And 21 to 30 years, here frequency 97 and percentage 46.2, and here total 210 patients, and their distribution is described here. Did you understand?
Yes, ma'am.
Okay. Now we will do any question here? So I am going to data view. Now you will do diastolic blood pressure for cutoff value. Here we define hypertension. If BP diastolic blood pressure is greater than 90 millimeter per mercury, then it will take hypertensive. We'll do it. Again, we transform and record into different variables. We select diastolic blood pressure. And in name box, diastolic blood pressure 1 is called diastolic hypertension. At the same way, we will record if hyper change old and new variable. Here we remove all the
Ma'am, can you please speak a little louder?
oh sorry. Okay. Now you see me? Sound is okay?
Yes, ma'am.
Okay. Now we will record diastolic blood pressure. Here we say 90, value range 90 to lowest. Record by 1, then OK. Now select range, value to highest 90, replace by 2 and OK. And continue and OK. Now from variable view, we see that the diastolic blood pressure DBP1, here decimal place is 0. Level at D hypertensive and value level, here we define 1 equal to 9 greater than or equal to 90 and 2 1 greater than or equal to 90, 2 greater than 90. Okay, now we see the data view. This is called DPP, diastolic blood pressure, DPP1. Now we go to analyze and descriptive statistics. Select frequency. Select D hyper. Click here, push them in variable box and OK. This is called distribution for diastolic blood pressure. Here we see that 90 less than or equal to 162. That is 77.1% is normal range, and greater than 90, that is 48. And 22.9% are hypertensive. Did you understand how we record the variable in different? Did you understand?
Yes, ma'am.
Any problem here? Then we go to again the spreadsheet. Now we will do data transformation. You know, the data that we collect for our studies are not normally distributed. Since parametric methods for testing hypotheses are more conclusive than the non-parametric methods. Data transformation are occasionally needed to make the distribution normal and to meet the assumption for a parametric test. Depending on the shape of the data distribution, there are several options for data transformation: log, square root, square, reciprocal, etc. The commonly used method of data transformation is log transformation.
Dr. Parveen, we cannot see your presentation. Are you using the PowerPoint presentation slides?
Sir,
Yeah.
I have no PowerPoint presentation here only.
I have shared with you.
Sir, data sheet দেখা যাচ্ছে না?
আমরা শুধু we can only see the output file.
Data view, sir?
No, we cannot see.
স্টপ শেয়ার দেখাচ্ছে।
আপনাকে যেটা বলছিলাম যে আপনি first of all you should select the whole screen. This is number one. Once you select the whole screen under sharing, under share screen, then select the desktop. Click on the desktop, then share, then click on the share. Then wherever you click, we can see your screen. Otherwise, I think there are problems like you that we are facing.
Okay, sir, I'll try it. না, সেটা যায়নি। ফুল দাও।
Yes. Now we can see your data view. Okay, please click on variable view. Let us see whether we can see it on. Please click on variable view.
Variable view. Sir, okay.
Click. So it's all right because it is the same file. Suppose you go to the output file now. Go to the output file. No, this is output file.
Variable view.
No, output file to a separate file, separate window.
Okay, sir.
No, we cannot see it.
Oh.
We cannot see the output file now. We cannot see it.
No.
Now we can see the output file. Please go to the data file. Now go to the data file, whether we can see it or not.
ম্যাম এটা মিনিমাইজ করে আরেকটা
No, minimize now. No, it is not because of this one, because this is because of I mean the sharing screen sharing option. No, we cannot see the data file. We can see the output file. Acha, for example, Dr. Parveen, can you get out of the screen sharing?
Okay.
Let me share my screen. I do not know whether you can see it or not. Just get out of here. Okay, say for example, if I share the screen, so can you see my screen? Perhaps not. Okay, once I click on share screen, on the top and left-hand side, you will see the screen, blue color and the desktop. Just click on it, then click on share. Okay, so can you see my screen?
Yes, sir.
Now I am going to PowerPoint presentation. Can you see the PowerPoint presentation?
Yes, sir.
So it should be like this. Wherever you go, for example, again, I am coming to, this is the output file. I am coming to data file. Can you see the data file now?
Yes, sir.
So it should be like this. Now I am on data view. Okay, you can see. Correct?
Yes, sir.
Okay, so it should be like this. Even if I go to MS Word, you will see. So can you see the MS Word file that I have opened?
Yes, sir.
Yes, sir.
So you see, it should be like this. You don't need to do anything else. So I think you are having problem. Dr. Parveen. Hello.
Sir.
Hello. Hey,
হ্যাঁ,
Dr.
yes,
Parveen.
sir. Yes, sir.
আপনাকে আমি স্ক্রিন শেয়ারিংটা দিচ্ছি। আচ্ছা,
স্যার,
আমি
এখন স্যার আপনি তাহলে আমার ওই যে ক্লাসটা শুরু করতে হবে তো আমি
okay,
Sir.
fine. Then I am continuing. Okay, fine.
Okay, sir.
No problem. Okay, that is very good. No problem. So let me open another presentation, data management. Okay, fine. Can you hear me?
Yes, sir.
Okay. Before analyzing the data, sometimes we need to manipulate the data. For example, if you look at the publications, or even whenever you write your or analyze your data for your thesis purposes, we provide tables like this. For example, age less than 20, 21 to 30, 31 to 40, something like this, right? We do it, correct? Hello?
Yes, sir.
So we call it data range. We want to make the data ranges. Okay, so we can do it automatically by SPSS. Second thing is that, as I have mentioned, for some analysis, string value variables cannot be used in SPSS. And for that purpose, it may be necessary to convert the string variable into numeric variable. Okay, fine. Am I clear?
Yes, sir.
So let us proceed one by one. First question is, how can we convert a string variable into a numeric variable? If we look at our data, we have a single string variable. What is that? What is that? 6. How it is coded? How it is coded?
Male, female.
Female.
No. Coding. How it is coded?
FM.
F and M. Okay, so small f and small m. Okay, So if we look at our data, in the data view, you can see it shows only F and M, correct? Can you
Yes,
see it?
Yes, sir.
Now we want to convert this variable into a numeric variable. Clear what I'm going to do?
Yes, sir.
yes, sir.
Okay. The way Dr. Parveen did is one way. There is another and easier way. Okay, let us see that easier way. Click on transform. Click on transform. Done.
Yes, sir.
Click on automatic record here, automatic record. Click on automatic record. Click on this. Have you done?
Yes, sir.
So we are here, correct? We are here. Select sex and push it into the variable new name box, okay? In this box, empty box. So I have shifted the variable, okay? Okay, fine. Have you done it?
Yes, sir.
Okay. The thing is that the computer will generate a new variable for sex, which would be a numeric variable. Clear? So computer will generate a new variable for sex, which would be a numeric variable. Am I clear?
Yes, sir.
Yes, sir.
So we have to give a new name. Just click on this new name box. Okay? Click on the new name box. Have you clicked?
Yes.
Yes, sir.
Now give any name you want, whatever you like. Okay? Give any name. What do you want to name? The new variable.
স্যার কিছু শোনা যাচ্ছে না।
শোনা যায় না? বলে কি? Okay, I am telling, give a new name, whatever you want. Can everybody hear me?
Yes, sir.
Okay, so I think it's clear. So what new name do you want to give? Huh? Can't you tell me any name?
Gender.
Huh?
Gender.
Okay, then write gender. Okay, write gender. Okay, am I clear?
Yes, sir.
Please be quick in response. Otherwise, the whole day will be passed without any progress. Okay, so we are going to generate a new variable, gender, which would represent the sex, and the variable would be numeric. Now click on add new name. Click on add new name. Okay. Done?
Yes, sir. Yes, sir.
Okay. Fine. Click OK. Click OK. Click OK. Have you done it?
Yes, sir.
Click OK. What do you see? You can
Sir,
see
one
that.
period.
So computer has converted F into 1, and 1 represents female, and M is converted to 2, which represents male.
Male.
Okay?
Yes,
Okay?
sir. Okay, sir.
Now let us go to, let me minimize it. How to minimize it? Okay. Now let us go to the data view. Okay, click here, go to the, sorry, a variable view. Click here and click here. So are you in the variable view now?
Yes, sir.
Yes, sir.
Can you see? Remember that whenever we generate a new variable, that will always appear at the last. So you can see that the last variable is gender that we have created. Can you see it?
Yes, sir.
Okay, you can see that here label, computer has given its own name, sex string. You can rename it, whatever you like, okay?
Yes, sir.
And computer has automatically provided the values. You can see one is female, two is male.
Male.
Okay, so to check it whether it is correctly done or not, you can always check with a frequency distribution analysis. So let us make a frequency distribution of gender. Okay, so go to analyze, descriptive, frequencies. Okay, just reset it, then select gender, which is the last variable, push it into the variables box. Okay? Okay?
Yes, sir.
Yes, sir.
You can also select sex, the original variable, and push it into the box. We shall see whether two tables are same or not. Okay? So select
Okay,
sex and push it here. Then click OK. And click OK. Okay. Now you can see sex string, that is the gender. 133 is female. The original variable sex is also 133. Okay, so it is perfectly done by the computer. Am I clear?
Yes, sir.
Yes.
Okay, now let us see how to make class intervals. Okay, how to make class interval. Okay, how to make class intervals. Suppose we want to record the variable age as less than 20, 21 to 30, and more than 30. And before making the class intervals, we shall have to decide what would be the code number for, say, this category, second category, and third category. Suppose we have decided to use less than 20 years of age, code number 1, 21 to 30, code number 2, and greater than 30, code number 3. Okay?
Okay, sir. Okay, sir.
Fine. Now, to do this, we have two options. Okay? To make the class intervals, we have two options. Go to transform. Transform. Are you here?
Yes, sir.
You can see there are two options here. Recode into same variable. Another option is recode into different variable. Okay. So if we use record into same variable, all the ages less than 20 will be 1. So original value will be deleted. Okay?
Yes, sir.
Therefore, we prefer to
Recording
use the record into different
different
variables.
variable.
So whenever we use this option, record into different variable, remember that always we shall have to generate a new variable. Okay? I shall have to generate a new variable. So click on record into different variable. Click.
There are some background noises, sir. Can't
Yes,
hear
I
you
know.
properly.
I know. I think please mute the microphone. So I think it's better now. So click on record into different variables. Click. Have you done it?
Yes, sir.
Okay. Now we see it is here. What variable we want to record? It is age, right? We want to make class intervals of age. So select age, push it into this empty box. Okay? Have you done it?
Yes, sir.
Now click on, you see output variable, click on the box under name. So this is the place where we shall write the new name. Okay? So what name do you want to give? What name do you want to give? Any name. No name? Can't you have any name in this world?
Sir, age 1.
Okay, you write age 1, age group, whatever you want. Okay, say we write age 1, but don't give any space after age. If you give space, computer will not take the variable name. So age 1, okay? And click under the level. Click in the box under the level. Okay, it's optional. You can write it here or you may not write here. So write age group because we are making the age group, correct?
Yes, sir.
So click on change. Click on change. Click on change. Change. Done.
Yes, sir.
Okay, so you can see in the box that age arrow age 1. It means that age would be recorded into age 1. Okay? Can you see this?
Yes, sir.
Yes, sir.
Now click on old and new values. Old and new values. Click on this. Okay. Click.
Done, sir.
Click on new values. Okay. Now the thing is that you see if there is any missing data in the data set, we shall have to take care of it. Okay. And earlier we have seen that missing data can be of two types. One is system missing. Okay. That means the boxes were empty. So we shall have to separately handle them. So the best practice is that on the left-hand side, it is the old value. You see old value. Select system missing from the left-hand side. Selected.
Yes, sir.
On the right-hand side, select system missing, the new value. Okay, have you done it?
Yes, sir.
Click add, click add. Click add, okay? So we can see systems, sysmis, okay? Can you see it?
Yes, sir.
What does it indicate? It indicates that if there is any system missing in the variable age, those system missing will remain in the new variable age 1, okay?
Yes, sir.
So if we use any missing value for age, that should also be recorded as missing value. For example, if we had a missing value for age, which was 99, so write 99 under the value, old value, then we shall use the same value in the new value, 99. Okay, so that missing value will remain as missing values. Clear?
Yes, sir.
Okay, then add. Okay, say 99 equal to 99. Then we said that the age of the individuals less than or equal to 20 will be coded as 1. Okay, so look at here. We said that less than or equal to 20 will be coded as 1, correct?
Yes, sir.
So we shall
Yes,
have
sir.
to use like this. Now come to, you see, range, lowest throw values. Select this one. Lowest throw values means if we write 2NT, it means that all the values 20 and below, okay, that is less than or equal to 20. Clear?
Yes, sir.
So that would be coded as 1. So write 1 under the new value, okay, coded as 1. Clear?
Yes, sir.
So add. Okay, so we can see lowest throw 20 is equal to 1. Then our next range is 21 through 30. So select this range on the left-hand side, old value. Okay, select range. Write 21 in the upper box and 30 in the lower box. Okay, have you done it?
Yes, sir.
So this would be coded as 2. So write 2 under the new value in the box value. Okay. Write 2, add. Okay. Done.
Yes, sir.
So next is all the values greater than 30. So we have two options. You see, range, value through highest, or all other values. We can easily use all other values because there is no values. I mean, this option will represent the data which are greater than 30, all other values. Okay, or if you use this one, so you can use 30, okay, whatever you like. So it is easier to use this one, all other values, and give code 3, add. Clear?
Yes, sir.
Clear? Then continue, okay. Continue, okay. Continue, okay. Done, continue, okay. Now go to variable view. Variable view options. You can see, I have said that whenever we shall generate a new variable, that would appear at the end of the variable list. So we can see that we have a new variable age 1. Can you see it?
Yes, sir.
Yes, sir.
So the label is age group, but there is no values, okay? There is no values. Do you see this one? There is no values.
Yes, sir.
So
Yes, sir.
what happens if we do not give any value here? So let us make a frequency of age 1. Analyze descriptive frequencies, age 1. Reset age 1, okay? Age 1, then okay. Then okay. You can see that the SPSS is showing 1, 2, 3. Correct? Can you see it? Can you see it?
Yes, sir.
So if you use this data file a few days, say after a few days, you may forget what does 1, what does 2, and what does 3 mean. What does it indicate? 1, 2, 3. Okay, you will forget. That's why we need to provide the values. Okay, that's why we need to provide the values here. So click on this 3-dot box. So value 1 is equal to, means less than or equal to 20, right? 20 years, correct? And you have already done it, so do it like this. 22 is 21 to 30 years, and 3 is greater than equal to 30 years. Okay, have you done it?
Yes, sir.
Okay. Now you find the frequency distribution of age 1. Say analyze descriptive frequencies, age 1, just okay. You can see now it's very clear, correct? Correct?
Yes, sir.
Okay, so this is how you can recode your data based on the class interval you want. Okay, whatever the class interval you want, you can manipulate the data. Am I clear? Am I clear? This is
Yes, sir.
given.
স্যার আমাদের হচ্ছে
বলো।
স্যার আমি কি বলবো স্যার 21
হ্যাঁ।
21 থেকে 30 যদি আমরা 2 ধরি তাহলে স্যার ওখানেও তো স্যার 30 ইয়ার্স ইনক্লুড হচ্ছে আবার স্যার মোর দ্যান অর ইকুয়াল 30 যদি ধরি 3 তাহলে তো স্যার
Okay, here the computer, there is a method of exclusion and inclusion. Okay, here the computer would consider up to 30 in the upper range and in the lower range more than 30. The computer program is set like this.
Okay, sir.
And it is better if you use the else option, all other values. Okay. Have you got it?
Okay, sir.
Okay, fine. So, okay. Any other question?
Yes, sir.
Any other question?
স্যার এটা বইতে কত পেজগুলিতে লেখা আছে স্যার?
Yes, I'm telling you. Okay. Page number, recording of data, page number 35. Page number 35, and you will find it. Okay, so this particular issue, making class interval, is given into 6.3, page number 39. 6.3, page number 39. Okay. Okay. Have you got it? Have you found it?
Yes, sir.
So you can use the book as well. So page number 39. Okay. Fine. Am I clear?
जी sir.
Okay.
Yes, sir.
Now, suppose you have the data on systolic blood pressure. Okay. Now your objective is to understand how many of your study subject have systolic hypertension. Or in other words, you want to know what is the prevalence of systolic hypertension. In such a case, we shall have to define what is hypertension, systolic hypertension. Suppose we define systolic hypertension as systolic blood pressure more than 140 millimeter of mercury. Okay. If the blood pressure is more than 140 millimeter of mercury, those would be considered as having systolic hypertension. Okay. So
Okay,
we can find what is the prevalence of systolic hypertension. To do this, go to transform, recode into different variables. Always I say to select, recode into different variables. Okay. Select, record, click on it. Have you done it?
Yes, sir.
Okay. Before that, let me check whether the data, have we used any, say, systolic blood pressure. Suppose I am adding, you can also add, say, missing data is 9. Okay. Missing value is suppose 9. Okay. Please, can you add it on your computer?
Yes, sir.
So systolic blood pressure, under the missing column, click on the 3-dot box, select discrete missing value, just put 9. That's all. Okay. Click OK. Have you done it?
Yes, sir.
Okay, very good. Now, say, let us go to data view, systolic blood pressure. Okay, you see, make the data 1 and 2 99 as missing value. Okay, just make this as a missing value. Just replace 107 as 9 and 105 as 9. Okay, I'm just replacing it. Have you done it?
Yes,
Yes.
sir.
Okay, now because I am doing it, what happens to show you? Okay, fine. Now, if we take a frequency distribution of systolic blood pressure, you see descriptive statistics, frequency, distribution of systolic blood pressure, you can see, okay, you can see that, you see the missing 9, 2. Can you see it on my computer? You can also do it, and you can also observe on your computer. Can you see that there are 2 missing values as 9?
Yes, sir.
Okay, we can see it, correct? Okay.
Yes, sir.
Now we shall transform the data to identify what is the prevalence of systolic hypertension. Go to transform, recode into different variables. Okay. Now reset, click on reset, reset. Then we shall be here. So have you done reset? Huh?
Yes, sir.
Yes, sir.
Select systolic blood pressure, push it into the empty box. Okay? Have you done it?
Yes, sir.
So
Done.
as I have mentioned earlier, whenever we shall use the option decode into different variable, we shall have to generate a new variable. So we shall have to give a new name. So let me name it S hypertension, S-H-Y-P-E-R, S hyper means systolic hypertension, and label it systolic hypertension, okay? Have you done?
Yes, sir.
Okay. Now click on change. Click on change. Click on change. Okay, have you done it?
Yes, sir.
Yes,
Okay.
sir.
Okay. Now click on old and new values. Click on old and new values. Have you done it?
Yes, sir.
Okay. Now I am just doing, if I say that hypertension means I said greater than 140. Okay. Am I correct?
Yes, sir.
So there is another range, that means from lowest up to 140 is normal, correct? So let us use this range, lowest throw values 140. And let us give the code number for this range as 1. Okay, so if the blood pressure is less than or equal to 140, then it would be coded as 1. So write 1 in the new value. Okay, I have written 1. Can you see it?
Yes, sir.
So all other values means above 140. All other values say the code number would be 2. Okay. Oh, sorry, I did not add it. So range 140 equal to 1, add. We shall have to use add. Okay, add. Then all other values would be equal to 2. Clear? Add.
Yes, sir.
Clear? Continue. Okay. Continue. Okay. Okay. Done. Done.
Yes. Yes,
Yes,
sir.
sir.
Now, if we look at the that variable view, you can see that we have a new variable S hyper, which indicates systolic hypertension, right? Systolic hypertension. Now let us take a frequency of this variable. Analyze descriptive frequencies, remove it, the last S hyper, okay? Let us make it okay. Now, do you see any missing value here?
No, sir.
So you say, so there is a problem because you had some missing value, which we did not handle it separately. Therefore, this problem has arisen. Okay? That means we have suggested the computer to consider any value less than or equal to 140 as 1. Therefore, the missing values have been included here, which is not correct. Okay? Now, how to handle it? That's why, again, go to transform, recode into different variables. Are you with me?
Yes, sir.
So just click here. Say we have, let us generate a new variable. So let us name it S hyper 1 this time. Okay? S hyper 1. Okay, click here, S hyper 1, change. Have you got it?
Yes, sir.
Yes, sir.
So old value, new values. Okay. Old value, new values. Okay.
Yes, sir.
Click on these values, then remove. Okay, lowest throw 140 equal to 1, just remove. Then else equal to 2, remove. Okay, I have removed them. Clear?
Yes, sir.
Now click on the value, write 9, because 9 was our missing value. So again, we are also telling new value is 9. Okay? Have you done it? Old value 9, new value is also 9. Okay? Add, click on add. Okay? Have you got it?
Yes, sir.
Now, perhaps I'm not sure. Let me try. Don't do anything. Let me check it. Don't do it, okay? It's all right. Okay, fine. Okay, where I was here. Transform, then recode into different variable. Say we were here, right? Here, we were here, correct? Correct?
Yes, sir.
Okay. Now we have said to the computer that use the old value 9 and also keep it same as a new value. Okay. Okay. Okay, am I correct?
Yes, sir.
So now select range. lowest throw, right? 140. Now I'm telling the computer that all the values less than 140 would be equal to 1. So write 1 in the box value under new value. Okay?
Yes, sir.
Okay, add. Then all other values means any value greater than 140 would be coded as 2. Okay? Add. Okay, done. Done.
Yes, sir.
Okay.
Now continue. Okay. Continue. Okay. Now make a frequency distribution of the new variable S hyper 1. Analyze descriptive frequencies hyper 1. Okay. S hyper 1. Then okay. Click on OK. Have you got it?
Yes, sir.
So what can we see? Now you can see 9 is remaining as it is and the frequency is remaining same. Okay? Is it all right? Is it okay? Okay, ঠিক আছে?
জি স্যার।
Okay, so we shall have to define the values under the value column. So click here. Here you see one is normal. Okay, because they had blood pressure less than or equal to less than or equal to 140. Okay, normal. And 2 is hypertensive. Okay, means greater than 140. Okay, add. And 9 is the missing value, correct? 9 is the missing value, correct?
Yes, sir.
Okay. Then, okay, then you can also define the missing value under the missing here. Just write 9. Okay. So have you got it now?
Yes, sir.
So we can say that the prevalence of the systolic hypertension is how much? We can see that the prevalence of systolic hypertension, we shall take the, which one? Valid percentage, because there are missing values. Prevalence of systolic hypertension is 26.4%. Okay, now can you do it? Can you do it? Can you do it now?
Yes, sir. করেছি স্যার।
Okay, and বলছি, can you do it in the future?
Sure, sir.
Okay, so I think it is, time is already over. Let us conclude here. But before that, do you have any question? Any issue? Anybody? Tamanna, do you have any question, any issue? Dr.
No, sir.
Tamanna.
No, sir.
So could you understand?
Yes, sir.
Okay. Dr. Nazmul, Dr. Kamrun, Dr. Jannatul Firdaus, Dr. Asma. Do you have any issue, any problem?
স্যার
কোনো সমস্যা, anything?
এখনো পর্যন্ত সমস্যা দেখছি না, তবে তারপরে যদি কোনো সমস্যা মনে হয়
আপনার কথাটা না খুব আস্তে শোনা যাচ্ছে, আর একটু জোরে বললে।
স্যার বলছি ক্লাসটা রেকর্ডেডটা আবার দেখবো, তারপরে যদি কোনো প্রশ্ন থাকে নেক্সট টাইম বলবো। আসলে খুব মনোযোগ দিয়ে ক্লাসগুলো করা হয় না, বিভিন্ন ইস্যুজ এর জন্য, ফ্যামিলি ইস্যুজ এর জন্য দেখা যায় যে খুব কনসিস্টেন্টলি করতে পারছি না, ডিস্টার্ব হয় অনেক ফ্যামিলিতে আর কি। রেকর্ডেডটা দেখে স্যার কোনো প্রবলেম হলে নেক্সট ক্লাসে বলবো স্যার।
Okay, next please raise them in the next class. If necessary, we shall redo it. Okay. We shall redo it, no problem.
Okay, sir.
Okay. Then Al-Afro Sultana Ferdowsi, Allama Faisal, Pallavi Borua. Any problem?
স্যার আমার ভ্যালিড পার্সেন্টেজ একটু চেঞ্জ আসছে মনে হয় স্যার, আমি এটা কি SPSS মানে ভার্সনের জন্য?
No, not because of the version. That could be your data may be a little bit different than me. That's why. Computer will never make the mistake in calculation. Okay.
Okay, sir.
The thing is that if you get the output, that's perfect.
Yes, sir, I got that.
Okay. Don't worry about what is the value, whether it is same as me or it is different. It may be different if there is little change in the data set. Okay. So any other problem? Any other problem? Then Nusrat, Dr. Nusrat, Noman Amin, Naurin, Rehnuma, Irtiza. Any problem so far? Any problem?
No, sir.
Everything is okay?
Yes, sir.
Okay. Mithila, Tahmina, Monica, Madhumita.
Yes, sir.
Any problem?
Actually, sir, practice করার পরে next class এ স্যার মানে করা যাবে যে আসলে প্রবলেম যদি থাকে তাহলে discuss করতে পারবো।
Okay. Please do it just do it just look at the book. In the book I have written it step by step how to do all these things.
Yes, sir. Yes, sir.
Then Mustafa, Faisal, Sayyida Jannatul Firdaus, Imran. Any problem? Mustafa, Faisal, Jannatul Firdaus, and Imran. Any problem? Are you here in this session or not? Maybe they have left, huh? Fine, okay. Rokeya, Shoibal, NC, Manisha.
Sir, the class was fine.
Any problem? Did you face any problem?
No.
Okay, these are very simple things. Okay. Shoibal.
স্যার আমি ঠিকমতো ফলো করতে পারছি।
Okay, very good. Okay. Then Asma. Anwar ki join করছেন? Anwar. So Asma, Anwar, nine. Okay, fine. The thing is that, okay, please try at home. If you face any problem, we shall discuss once again. There is no problem. Okay. So if you do not have any question, any problem, so we are going to conclude this session for today. Thank you very much.
Next class?
Next class next Friday. Next Friday te ekhono roja shuru hobe na, tai na? Gabriel?
Sir, next Friday or Saturday?
Oh, Saturday.
Sir, Saturday, sir, first rojar
first Ramadan? Oh,
sir,
okay.
first Ramadan নামাজ থাকবে স্যার 7টার
okay.
দিকে যদি শুরু হয়।
Okay, okay. In that case, let us omit the next class and we shall start the classes after the month of Ramadan and we shall inform all of you through email.
Sir, Eid may be celebrated on 2 or 3 May, sir. And after Eid, the first Saturday is 7th May.
Okay, I think we shall write them an email. If they have any concern, I think we can ask their opinion as well. But tentatively, let us fix the date 7th May to resume the classes.
Okay.
Okay. So is it all right?
Yes, I will send everyone.
Yeah, we shall communicate with you through email and we shall resume the classes after the month of Ramadan, hopefully from 7th May. And if necessary, in the first class, we shall review the previous classes. Okay, no problem. Yes, please stop recording, no problem.